One very good morning. I hope each one of you are doing well. So today in the class, what we will be doing is we will be first solving questions from capacitor, and after that we will be moving on with magnetism. Okay. So let's start with this thing. Let's start with the question because already in the previous class we have done one question, and in today's class we are going to do such more questions, and in the end we will be wrapping up whatever formulas we encountered in capacitor or whatever additional concepts we need to have in our mind. Okay. So that I will do for you in the end after you will be done with the questions. So let's start with the questions. This is the very first question for today. I will be launching the poll. Everyone take your time and do it. My screen is visible, right? Everyone can see the question? Okay, very good. This question came just previous year. So just look at the question, how easy questions you people are getting. I expect each one of you to answer this question. So far, I got just one answer. Others, please. Answers? Okay, I'm ending the poll because you don't need to solve this question. You just need to have the information. The capacitance of a capacitor with charge Q and potential difference V depends on what factors, sir? No. कैपेसिटेंस कैसे लिखते हो? Q इज इक्वल टू सी भी लिखते हो. अगर आप ऐसा सोच रहे हो C इज इक्वल टू Q by V, so C will depend on Q and V. It's not the case actually. It's not going to happen. Why? Because we have already studied capacitance depends on the geometry and the media. ठीक है. Capacitance का formula जो आप लिखते हो epsilon naught A by D, and for different structures, like in the class I have done it for cylindrical capacitors and all, but questions generally come from parallel plate capacitor. We have to focus on that. But whatever be the case, capacitance depends on geometry. That is, A here is the area of plate, D is distance between two plates, and epsilon naught indicates that these two plates are kept in vacuum. That is, this media, this space is getting covered by vacuum. If it is air, if it is certain media, then epsilon naught will get replaced by epsilon. ठीक है. और यहाँ से एक चीज और याद रखना, एप्सिलन इज रिटन एज एप्सिलन नॉट एप्सिलन आर, and this epsilon r written as epsilon by epsilon naught is also called as what is that, dielectric constant. Okay, so this epsilon r is also called dielectric constant, and generally dielectric constant ko we indicate by letter k. So this epsilon r is nothing but the dielectric constant. So capacitance will depend on the geometry of capacitor and on the medium. So option B will be correct here. Nothing is mentioned about the media, so we don't need to care about. getting answers, meaning you're not clear of this concept, I guess. Is it the case? कोई नहीं, चलो. Let's do it together now. I will explain certain things so that your concept will get more clear. See here, what's the thing? The steady state current in the circuit shown below. What do you mean by steady state? Steady state meaning after long time. And you must have studied after long time, capacitor behave like what? It behaves like what is that called? Insulator. Okay. So after long time, in whatever branch there is capacitor, that branch will offer very high resistance. So after long time, yaad rakhna, capacitor behaves as insulator. Okay. Same question if it comes with inductor, then after long time, inductor behaves like what? Conductor. Because in AC circuit, you may get questions like, or in our DC circuit itself, there may be inductor in one of the branch, and then you are asked current in a steady state. So inductor behaves as conductor, that is conducting wire after long time. So after long time, what happens to capacitor and inductor? You should know about this. Now let's come back to the question. Here there is one capacitor, and this capacitor is connected in this arm. We are asked current after long time. So this capacitor after long time will offer infinite amount of resistance. So what the circuit will look like in that case? Here it will be 2 ohm. Here this is 10 volt. And since this is offering infinite amount of resistance, there will be break in the circuit because of capacitor. And then there is 5 ohm here. Okay? And then there is 3 ohm. Done. Now let's drive current out of the battery. So if you're driving current I out of the battery, I will come here. Will I go to the branch AB? I will not go through the this current I will not get divided to the branch AB because AB branch is not complete. There is break in the branch. There is break in the circuit. So इधर current नहीं जाएगा. Done it? So whole current will go like this. It means what the circuit will appear? Circuit will appear like a single loop circuit. There is 2 ohm here. This is 10 volt. And then this 5 ohm. That middle one will get cancelled, will get erased out of the circuit. Okay? Now what is the current? Now everyone can see here, current will be 10 divided by 5 plus 2. That is your, sorry, this is 3, right? 3 plus 2, that is your 5 ohm. So current will be 2 ampere. So correct answer will be third. So always remember this thing, when capacitor is in steady state, it will behave as an insulator. Inductor behave as conductor after long time. Means a steady state. And when initially, if you talk about, agar question mein diya hota initially, that is at time t equal to 0, not after long time, just after the circuit is closed. Then opposite will happen. Capacitor will behave like conductor and inductor will behave like insulator. Remember these things. ठीक है? So at t equal to 0, capacitor किसकी तरह behave करने वाला है? Capacitor will act like a conductor. And inductor will act like what? Inductor will act like insulator. These are the things. Clear है everyone? Anyone having any doubt? Facing any doubt? If yes, let me know. किसी को doubt है तो बता दो. Yes? Nobody? Chalo, let's move on with next question. So this is your next one. Do this question, let me know your options in the poll. You can also let me know in the chat section, wherever you feel comfortable. Okay. One answer I got. There, yes, that's great. Very good. शरद सही से सॉल्व करो. Shruti, yes. Puneet, yes. Very good. That's great. So everyone can crack the circuit, right? This circuit is looking like what sort of a structure? Wheat stone sort of a structure. Sarath, yes, very good. So if you look here, there is one capacitor here, then another capacitor here, one capacitor here, another capacitor here, and then there is one capacitor combining these two. So this is one arm, this is another arm, and this is in middle. If you look at the capacitance thing, जैसे how we check Wheatstone bridge carrying resistors is balanced one. So for that, what we do, we see if it's resistance, if there is a resistor here, and here, and here. What we do is, if this is R1, this is R2, this is R3, this is R4, we do R1 by R2 is equal to R3 by R4. If this is the true, then this is balanced. And if it is balanced, no current will flow here. Similarly, if C1 by C2, that is 2 by 2, if it is equal to C3 by C4, that is 2 by 2, then there will be no charge or no potential difference across this middle 2 microfarad. What does it mean? It has a simple meaning that this capacitor and this capacitor will look like this. This will look like this. Because middle one, there is no potential difference, no charge. So no current will flow in that arm. Done it? This is 2, this is 2, this is 2, this is 2. These two in series will get added like parallel, and you will be getting what? 1 microfarad, 1 microfarad, and then 1 will be in series. So it will get reduced to something like 1 above and 1 below. Okay? So 1 microfarad in parallel will get added like series, 2 microfarad, 1 will be the answer. Okay? Now do this question. This is a question from displacement current, and displacement current is in the last chapter of first part of physics in class 12. If you have forgotten it, I will let you know. Displacement current is basically equal to the steady state current, whatever you get. And its formula you can write as epsilon naught d phi e by dt, where phi e is what? Electric flux between the in between the plates of capacitor. Okay? So this is the formula you have to use. And this question again came in NEET 2024 or 23, like that. तो नीट का ही क्वेश्चन है, रिसेंट क्वेश्चन इट इज. ठीक. सरल नहीं. Check once more. Do it more properly. Okay, two answers. Both are wrong actually. Okay, one correct answer so far. So far, four answers, one correct out of all. Yes, Ruti, that's great. Okay, let me end the poll here because whatever you know, you have already answered. Yes, Kunit, that's correct. So just read the question. To produce an instantaneous displacement current of 2 milliampere. So the value of this displacement current is 2 milliampere in the space between the parallel plates of capacitor of capacitance 2 microfarad. So this is the parallel plate capacitor, and capacitance is 4 microfarad. It means 4 microfarad is equal to epsilon naught A by D, where A is the area of the plate and D is this distance. Okay? Now, the rate of change of applied variable potential difference dV by dt must be. So displacement current is given, that is 2 milliampere. So let's write here 2 into 10 to the power minus 3 is equal to epsilon naught. Just give me some time. Let me write it in the middle so that there won't be any cramp thing happening over the board. ID क्या लिखोगे? This is already known. 2 into 10 to the power minus 3 milliamp minus 3 ampere, I would say. Epsilon naught d by dt. D by dt of what? Pi e, which is what? Electric flux. Electric flux, how you will be writing? So if this plate is having positive charge and this plate is having negative charge, then there is electric field in this region, right? And in this region, how much flux is there? So what is the area? If you see here, any area if you take here, this cross section will have the same area as that of the area of the plate. So flux through any segment in between the plates of capacitor will be equal to how much? E into A, where E is what? Electric field. Done है? अब देखो इसको और हम कैसे लिख सकते हैं? ए को आप बाहर ले लो, एप्सिलॉन नॉट ए डी बाई डी टी. इलेक्ट्रिक फील्ड को क्या लिख सकते हैं? लेट्स से पोटेंशियल डिफरेंस बिटवीन द प्लेट्स इज V. If potential difference is V, then you already know V can be written as ET. If electric field between the plate is E and distance between plate is D, then potential difference can be written as E into D. क्योंकि आपने पढ़ा है dV इक्वल टू क्या होता है? E डॉट dl माइनस E डॉट dl. So here potential difference is V. Electric field and डीएल के बीच का डिस्टेंस सॉरी एंगल क्या है? दैट इज 0 डिग्री. सो ओवरऑल इफ यू टॉक अबाउट द मैग्नीट्यूड, देन पोटेंशियल डिफरेंस इज इक्वल टू ई इंटू टी, because here you will get minus e dl cos 0. dl is d, right? E is e. Cos 0 is 1. Magnitude wise if you take v equal to et. So इसलिए यहाँ पे मैं क्या लिखूंगी? इलेक्ट्रिक फील्ड को मैं लिखने वाली हूँ वी डी. ठीक है, बाई डी टी. So again you take this what? Sorry, इलेक्ट्रिक फील्ड लिखना था ना हमें, V by D होगा, है ना? नॉट वी डी. सॉरी, इलेक्ट्रिक फील्ड को क्या लिखोगे? V by D. Now take this D out because that is also a constant. Epsilon not A by D equal into dV by dt. So dV by dt का वैल्यू क्या होगा? This is your current, right? Epsilon naught A by D is what? C. That is 4 microfarad. So this is 2 into 10 to the power minus 3 is equal to 4 into 10 to the power minus 6 into dV by dt. So if you calculate here, 2 से 2 cut हो जाएगा and this will become 1000 by 2. So dV by dt is equal to how much? This is equal to 1000 by 2 and that is equal to 500 volt per second. So this is going to be your answer. This is how you can attempt such questions. So displacement current में always remember displacement current is written as epsilon naught d phi e by dt. ठीक है, एक बार और मैं बता देती हूँ. Phi e क्या होगा? Flux in the region of this in this region of the plate. So if you take here any segment like this, then flux through it will be equal to how much? E into A. अगेन फ्लक्स तुम इतने छोटे एरिया के लिए भी ले सकते हो, बट इट इज वाइज हियर टू टेक एरिया एज बिग एज द plate of the capacitor, because then you already know the area, because if area of plate is given as A, then through A you can calculate flux. That is why here you can write epsilon naught d A into E by dt. So if question is getting asked about voltage thing, then try to convert electric field into voltage. And if this distance is d and potential difference is V, or electric field is E, then V can be written as ED. So you can interchange things and you can write accordingly, whatever is asked in the question. Okay? Chalo. Now let's do this question and try to understand the concept. This is a very important concept, I would say. थोड़ा अच्छा कॉन्सेप्ट है ये. और शरद, नो, एक बार सही से चेक करो. Concept is good, but question is easier, I would say. Two answers I got, both are incorrect. Let me end the poll here and let's do it together now. ठीक है. श्रुति नहीं. Let's see where you people are getting stuck. So initially we have a capacitor. ठीक है. Initially we are having a capacitor. Puneet, yes, very good. So this capacitor is having capacitance equal to 900 picofarad. And what is happening? This is connected to a battery of potential difference 100 volt. Okay. So initially, how much charge it will be having? Just look over how much value of charge it will be having. Just give me some. Sorry. So how much charge it will be having initially? So initial charge on the capacitor is how much? Q equal to CV लिखोगे. C is how much? 900 picofarad. So this into 10 to the power minus 12 into 100. So this will become 9 into 10 to the power minus 8 coulomb. ठीक है, this much charge it is having. Now what we are doing to this capacitor, we are disconnecting the battery. So let's disconnect the battery. So initially, when it was connected to battery, this plate will have positive charge, this will have negative charge. So this has a positive charge, this has a negative charge. Now what is happening? This is getting connected to another capacitor, which is having no charge, right? So what will happen? Yes, Shruti, that's correct. Now what will happen here? Now, whatever charge it is having 8 into 10 to the 9 into 10 to the power minus 8 coulomb of charge. Charge from this plate will start traveling to this capacitor, because there is potential difference. Here it is having 100 volt of potential difference. Here potential difference is 0 initially. So charge will flow from high potential to low potential. Okay? And how long will the charge flow? Until potential difference between both the plates is becoming same, right? So let's say finally in a steady state, this is the case, then done. So in this case, what will be happening? Potential difference across both the plate will be same. So let's say potential difference is V. This has a capacitance C. This also has a capacitance C. So now what will be the charge on first plate and charge on second plate? Or charge on first capacitor and charge on second capacitor. So charge on first will be CV and charge on second will be also CV. It means now total charge is equal to how much? अगर आप total charge की बात करो तो 2CV. Done. And initially this system is having how much charge? 2CV. Initially this system was having how much charge? This was having 0 charge. This was having 9 into 10 to the power minus 8 coulomb of charge. And finally 2CV. So charge will be conserved because from one plate it is going to another. Charge is not going anywhere outside. So charge will be conserved. So 2CV को आप क्या लिखने वाले हो? 9 into 10 to the power minus 8. ठीक है. एंड 2 इंटू सी को क्या लिखोगे आप? सी इज व्हाट? 9 इंटू 10 टू द पावर माइनस 12 इंटू वी इक्वल टू 9 इंटू 10 टू द पावर माइनस 8. यस. सो यहां से अगर आप कट करते हो, सो दिस विल गिव यू वी इज इक्वल टू हाउ मच? आई मीन देखो यहाँ पे पावर में कुछ गलत तो नहीं हुआ है ना? दैट इज ऑल्सो 900 पिकोफैराड. सॉरी, यहाँ पे 900 लिखना होगा मुझे. सॉरी, यहाँ पे 900 पिकोफैराड लिखना है. ठीक है. तो मैंने सिर्फ 9 लिखा. 900 पिकोफैराड करूंगी तो क्या हो जाएगा? 10 टू द पावर माइनस 10. डन है. सो वोल्टेज कितना मिलने वाला है हमें? वोल्टेज विल बी 100/2. दैट इज इक्वल टू 50 वोल्ट. यानी कि दोनों कैपेसिटर के क्रॉस अभी वोल्टेज क्या है? 50 वोल्ट. व्हाट विल बी द फाइनल एनर्जी स्टोर्ड? तो एनर्जी स्टोर्ड क्या लिखोगे? दोनों ही कैपेसिटर पे एनर्जी होगी हाफ सीवी स्क्वायर प्लस हाफ सीवी स्क्वायर. सो टोटल एनर्जी स्टोर्ड इज सीवी स्क्वायर. सो you can write it now. C is equal to how much? C is how much? 900 into 10 to the power minus 12. V is how much? 50. So 50 into 50. ठीक है. 5 into 5, 25. 25 into 9 will be equal to how much? That will be equal to 2 to 5. And 2 to 5 into what power? 1, 2, 3, 4, 10 to the power minus 8 joule. That is 2.25 into 10 to the power minus 6 joule. ठीक है. अब देखो ऐसे क्वेश्चंस को ना हमें बहुत ही अच्छे से करना चाहिए. जैसे मैं फिर से एक्सप्लेन करती हूँ. देयर वाज वन कैपेसिटर व्हिच वाज इनिशियली चार्ज. So it was initially having a charge of, suppose, let's say Q naught charge. Finally, let's say its initial capacitance of this capacitor is CV. Let's say finally it is getting connected to any other capacitor C2. So what will happen? Charge will flow until potential difference between two will become same. It means finally the C1 and C2 will be in parallel. Finally. So ये सारी चीजें दिमाग में रखो. Finally C1 and C2 will be in parallel. क्यों? क्योंकि potential difference between both is becoming the same. Done it? And also initial charge is Q naught. Then it's Q naught. Finally potential difference is becoming same. Let's say potential difference between this plate is V. Then between this plate will also V. Then so final charge will be equal to C1V plus C2V. So from here you can directly calculate potential, new potential Q naught by C1 plus C2. And here C1 and C2 were equal. So and Q naught was equal to CV naught. ठीक है. So that is how we क्योंकि यहाँ पे अगर तुम इस क्वेश्चन के लिए रखोगे तो Q naught को क्या लिखोगे, CV naught, and this C1 plus C2 is 2C. So directly from the formula, V will become V naught by 2. Then finally you may be asked what is the final energy stored. So final energy stored क्या लिखोगे? Final energy stored क्या हो जाएगा? This will be equal to half C equivalent into V square. And since C1 and C2 are in parallel, they will get added like in series, half C1 plus C2 into V ka square. And here C1 and C2 were equal, so this became 2C. And 2 cancel हो जाएगा, final energy was CB square. Initial energy of the system क्या था? Initially only first capacitor was charged. So initial energy अगर आप लिखोगे, so that was equal to half C1 or initial potential difference between C1 plates, that is V naught ka square. Sometimes it is asked what is the loss in energy. So for that case, you have to calculate final energy stored. You have to calculate what was the initial energy, and then you will be calculating energy loss. So basically, initial energy will be greater than final energy. So initial minus final. Where this final energy, where this loss of energy is going, so it is basically, it will appear as heat generated in the wire, I square RT के फॉर्म में वो wire में dissipate हो रहा है, right? So that is these are the some sort of question that you may be getting in capacity. Done है? So कैपेसिटर का और भी चीजें हैं जो मैं तुम लोगों को रिवाइज करवा दूं. डायलेक्ट्रिक का ज्यादा क्वेश्चन मुझे दिखा नहीं, बट आई विल टेक यू थ्रू what different sort of things you need to remember. So let's go through it. सबसे पहले बेसिक पे आते. If you talk about parallel plate capacitor, let's say it has area of cross section A, distance between plates is D, and this media is having dielectric or this media is other than that of vacuum, then capacitance you will write as epsilon A by D. Epsilon को क्या लिख सकते हो? Epsilon not epsilon R A by D. So basically, if in vacuum capacitance is epsilon not A by D equal to C naught, then in media it is C naught into epsilon R, that is equal to K C naught. So if in the question it is given that there is a capacitor and its capacitance is C naught in vacuum, and after that you are inserting dielectric in between the space of plates of capacitor, then what will happen to the capacitance? Okay, so what will happen to the capacitance? Capacitance will get increased by K times. Okay, first thing, we will later discuss what else will happen to all other variables, जैसे कि potential difference, electric field, energy and all. But before that, more formulas को हम देखते हैं. यहाँ पे if charge density on the plate, if charge density on the plate is sigma, then electric field between the plates of capacitor is written as sigma by A. ठीक है? This is written as what? Sigma by A. And what will be the potential difference? Sigma by A into D. What is the force acting between these two plates? So force acting between these two plates will be electric field because of any one plate, that is equal to sigma by 2A into charge on another plate. So that is equal to sigma into A. Okay? So force will become equal to how much? Sorry, this sigma by A nahi hoga. What I'm writing? I'm really sorry. Sigma by epsilon naught it is. If this space is occupied by vacuum, then it is sigma by epsilon naught. Sorry, A nahi tha. So sigma by 2 epsilon naught into sigma A. So answer will be sigma square A by 2 epsilon. So how you calculate force acting between two plates? Just see what is the electric field in between the plates of capacitor because of single plate. Total electric field is sigma by epsilon naught. But because of one plate, it is sigma by 2 epsilon naught. And force acting is equal to sigma by 2 epsilon naught electric field because of one plate into charge on the another. So sigma A. This is the force. ठीक है. एनर्जी स्टोर्ड आप लोगों को पता है हाफ सीवी स्क्वायर. एनर्जी स्टोर्ड को क्यू के टर्म में भी लिख सकते हो. चार्ज ऑन कैपेसिटर इज क्यू नॉट, देन क्यू नॉट स्क्वायर बाई 2c. So these are all the basic formulas. There is one important thing given also in your NCERT. There is capacitor and you are going to insert dielectric between the plates of capacitor in two ways. First thing is you have a charge capacitor. You have a charge capacitor like this. Okay. And here what is the thing? Let's say its capacitance is T naught and it has a charge Q naught on the plate. So on this plus Q naught, on this minus Q naught. Done it? And in second case also, same plus Q naught charge this is having, minus Q naught charge this is having, and this capacitor is connected still to the battery. Okay? Of potential difference B. But this capacitor got charged with the help of battery. After that, battery got disconnected. ठीक है, ऐसा कुछ हुआ. अब आप देखो मैं क्या कह रही हूँ कि फर्स्ट केस में भी वी आर पुटिंग डायलेक्ट्रिक इनसाइड. इन सेकेंड केस ऑल्सो वी आर पुटिंग डायलेक्ट्रिक इनसाइड. हाउ थिंग्स विल चेंज. सो इन फर्स्ट केस सबसे पहले दोनों केस के लिए हम लिखते हैं. सो इन फर्स्ट केस सी नॉट विल बिकम व्हाट, के सी नॉट, वेयर के इज द डायलेक्ट्रिक कांस्टेंट of that dielectric getting added. Here also C naught will become K C naught. Now let's talk about charge. What will happen to the charge? So here charge will remain same. Charge same रहेगा. क्यों? क्योंकि this capacitor is isolated capacitor. Then it is not connected to any other source. It is not connected to any other conducting things. That charge will travel to some other thing, right? So charge will remain same. Though capacitance has increased, charge will remain same on the capacitor. Here what will happen? If its capacitance is increasing by K C naught times, this capacitor is connected to the battery. So this battery will respond to increased capacitance. How it will respond to increased capacitance? जैसे हमारी भूख बढ़ जाती है, then we give ourselves more food. So here also plate capacitor का desire is more now. So this battery will fill this desire by giving it more charge. So here Q naught final charge will be greater than initial charge. And how much? Q naught will become, that will become your K Q naught, it will become almost, yes. So Q final will be equal to how much? K Q naught. ठीक है. Now let's talk about potential difference और electric field. चलो पहले पोटेंशियल की बात कर लेते हैं. सो व्हाट विल हैपन टू द पोटेंशियल डिफरेंस. मैंने बोला था ना पोटेंशियल डिफरेंस का फॉर्मूला क्या था, सिग्मा. इलेक्ट्रिक फील्ड का फॉर्मूला क्या था, सिग्मा बाय एप्सिलॉन नॉट. इफ दिस डिस्टेंस इज डी, देन पोटेंशियल डिफरेंस विल बी सिग्मा बाय एप्सिलॉन नॉट इनटू डी. ठीक है. सो इफ सिग्मा इज नॉट चेंजिंग, क्यू इज नॉट चेंजिंग, राइट. सो सिग्मा इज नॉट चेंजिंग, एप्सिलॉन नॉट इज चेंजिंग, बट है ना, because here you are adding dielectric. So it is no longer, its permittivity is no longer epsilon naught. It is becoming what? It is becoming epsilon. So new electric field here will be sigma by epsilon. And this is equal to how much? Sigma by epsilon naught epsilon r. So this is equal to how much? Epsilon r means k. So 1 by k sigma by epsilon. And sigma by epsilon naught is what? E naught. Done it. So final E will be what? E naught by K. And final potential difference will be what? V naught by K. Because this will become, initial was sigma by epsilon naught into D. Final will become 1 by K sigma by epsilon naught into D. That is V naught by K. Now let's talk about this case. So here there is a battery. And battery will make sure potential difference between these two plates is always same. Because plates के बीच का potential will be same as the potential difference of here, the plates here. I mean the positive terminal and negative terminal के बीच का जो भी difference है, that difference of potential will appear across the plates. Done it? So here potential will remain same. Final potential is equal to initial. And hence electric field is also same. It is equal to this. What is one more thing left? That is energy. एनर्जी के बारे में अगर आप बात करोगे, व्हाट यू विल राइट हियर. Q is remaining same, right? एनर्जी का फॉर्मूला Q नॉट स्क्वायर बाई 2C, है ना? और यहाँ पे C कितना हो रहा है? KC नॉट हो रहा है, देन so final energy is what? E naught by K. Energy is getting decreased by K times. And similarly, if you see here energy, इस केस में अगर energy आप लिखोगे तो half CV square. V is remaining constant. C is what? KC naught. So energy is becoming K E naught. Here energy is getting increased by K times. So this is the one clear difference we see in putting dielectrics when the battery is connected to the battery. Sorry, when the capacitor is connected to the battery, when capacitor is not connected to the battery. So these are the two different cases. ठीक है, डन है. उसके बाद तुम लोग डायलेक्ट्रिक का क्वेश्चन देखते होगे. इफ यू आर पुटिंग डायलेक्ट्रिक, सपोज टू डिफरेंट डायलेक्ट्रिक्स यू आर पुटिंग. This is K1 dialectic, this and in another half you are putting K2 dialectics. And now you are asked C equivalent. How you calculate? You just see how dielectric is dividing the capacitor. So here you can see initially there was one capacitor of area A, distance between plates D. So its capacitance is epsilon naught A by D. If one dielectric is getting added, capacitance will become K times that. Two dielectrics are there. How we will deal with this? So तुम्हें बस देखना ये है कि how dielectric is dividing the capacitor. So here dielectric is dividing capacitor into two portions. One is this one and another is this one. So sort of we are getting two capacitor. One is having area A by 2, done, and distance between plates still D, and dielectric in between is K1. Another is having area A by 2, dielectric K by 2, sorry, K2, and distance between plates still D. Are they in parallel or series? There are two capacitors, right? Are they in parallel or series? So whatever potential this plate is having, let's say V1, this plate is having potential V2. So potential difference between first capacitor will be V1 minus V2. And between these capacitors will be what? Plates of these two capacitors. Again V1 minus V2. क्योंकि इस पूरे प्लेट का पोटेंशियल V1 है, इस पूरे प्लेट का पोटेंशियल V2. So definitely these two capacitors are in series. Sorry, parallel. So हमारे पास दो कैपेसिटर मिला यहाँ पे पैरेलल में. एक का कैपेसिटेंस क्या है? एप्सिलॉन नॉट A by 2 divided by D into K1, और दूसरी का क्या है? Epsilon naught A by 2 divided by D into K2. You will add them in parallel. ठीक है. Another way of putting dielectric may look like this. This is the initial plate. ठीक है. We are putting dielectric like this. In one portion we have put in K1. In another portion we have put in what? K2. So एक portion में तुम्हारा dielectric क्या है? Here it is K1 and here it is K2. This is also dividing capacitor into two reasons. This is one reason, this one, and this is another reason, having K2, right? So two plates again. Are they in series or parallel? क्या दिख रहा है तुम्हें? Anyone? Are they in series or parallel? बताओ. सीरीज में है प्रसाद? Yes. How this is in series? Because it says there are two plates, plate 1, plate 2. Let's say plate 1 has a potential V1, plate 2 has a potential V2. And there is one imaginary line which is dividing K1 and K2. This is one imaginary plate. Then let's say here the potential is 3, यानी कि V3. So potential difference between first capacitor is V1 minus V3, and between another capacitor is V3 minus V2. Potential difference is different. They are in series. So we have two capacitors in series. Potential difference of this will be what? This also has a plate A, but distance is getting divided. Let's say this is D by 2 and this is another D by 2. So this is epsilon naught A D by 2 into K1, and this is how much? Epsilon naught A D by 2 into K2. So this is how you can do it. अभी तुम लोग मुझे एक सिंपल सी चीज बताना, ठीक है? चलो एक क्वेश्चन करके बताओ मुझे. दिस इज द डायलेक्ट्रिक, ठीक है? डायलेक्ट्रिक ऑफ डायलेक्ट्रिक कांस्टेंट K, एंड इसका थिकनेस है X. ये जो प्लेट था, इसके बीच का डिस्टेंस था d, एरिया ऑफ क्रॉस सेक्शन, एरिया ऑफ द प्लेट इज a, ठीक है। यू हैव टू टेल मी what is the capacitance of this system if capacitance of the capacitor without dielectric, that is epsilon naught a by d, was equal to c naught. So अभी c का वैल्यू क्या होगा in terms of c naught, that you have to tell me. चलो everyone try this. Okay, प्रशांत, no. के सी नॉट तो तब होगा ना जब पूरे ही स्पेस में डायलेक्ट्रिक है. डायलेक्ट्रिक इज नॉट इन द होल स्पेस इन बिटवीन द प्लेट्स ऑफ कैपेसिटर. दिस स्पेस इज वैक्यूम. दिस स्पेस इज स्टिल वैक्यूम. देर इज ओनली डायलेक्ट्रिक इन द विथ एक्स. ठीक है. सो यू नीड टू टेल मी आंसर इन दिस केस. लाइक, अंडरस्टैंड द क्वेश्चन फर्स्ट. ठीक है, सही से समझो. यस पुनित, बिल्कुल एक्सप्लेन करूंगी. क्वेश्चन ये है, देखो मैंने ये बोला कि we have a capacitor initially and area of plate is A. This is A. Distance between plates is D. ठीक है. And in this case, capacitance is equal to epsilon naught A by D है, and this is equal to C naught. So capacitance of plate initially is given, that is C naught. Now what we are doing, we are inserting a dielectric of thickness X. So we are inserting a dielectric of thickness X, dielectric of dielectric constant K, and its thickness is X. Area of dielectric is also A. So it is filling up the whole this portion. Then now you have to tell me what will be the capacitance of this capacitor in terms of C naught. Shreya, yes, it looks correct. Yes, it feels like correct to me. ठीक है, very good. Yes, I'm just waiting for more answers. ठीक है, just let me do one thing. चलो. Yes. So how you are going to do this question? सबसे पहले तो हमें ये दिख रहा है, we are able to see there are three plates, है ना, तीन प्लेट, तीन कैपेसिटर दिख रहा है. एक दिख रहा है ऐसा, where I mean this distance is how much? This is X. This whole was D. So region or width without dialectic is D minus X. So there are two such regions. One is this, another is this. So maybe this distance is D minus X by 2. This is D minus X by 2. Okay. So it feels like there are three capacitors in series. One is this D minus X by 2 with vacuum. I mean, there is vacuum in between plates. Then there is another capacitor with dielectric K. This width is X. And then there is third capacitor with distance between these two plates D minus X by 2. And the area of cross section is what? A. Take it? Done it? So when you will calculate it, like three capacitors are in series, you will add them like you add things in parallel, right? So 1 by C equivalent क्या लिखोगे? 1 upon C1, 1 upon C2 plus 1 by C3. You will put the values, you will get the answer. ठीक है? इसका area of cross section A है. सो इसका C1 का वैल्यू कितना होगा, एप्सिलॉन नॉट A बाई B माइनस X by 2, and what will be this one, C2 will be equal to how much, epsilon naught A by X into K, and what will be C3, same as C1. ठीक है, so C1 and C3 are same. अगर आप इसको ऐड करते हो तो what you are going to get, चलो एक काम करते हैं, 1/C इक्विवेलेंट को क्या लिखोगे, 1/C1 अगर आप करते हो तो what you will get, 1 by epsilon naught A, this will be 2 and D minus X plus X by epsilon naught A into K plus D minus X by epsilon naught A into 2. ठीक है, इन दोनों को अगर आप ऐड करोगे then both are same. If you will add it, you will get D minus X by epsilon naught A plus X by epsilon naught A into K. ठीक है, अब आप एक काम करो, 1/epsilon naught A को कॉमन ले लो, what you will be getting, D minus X plus X by K. So you simply solve it, you will get T equivalent. What I'm trying to say here is कि finally जब हम add कर रहे हैं ना, what we are seeing, we are seeing that we are adding two capacitors. One is this and another is this. इसके कहने का सिंपल मतलब ये है कि इफ यू आर गिवन टू कैपेसिटर्स, सॉरी वन कैपेसिटर, एंड देयर इज वन डायलेक्ट्रिक ऑफ एनी थिकनेस T placed in between the plates of capacitor, then you will get simply two capacitors. One will be capacitor of distance T between the plates having dialectic K in between, and another capacitor will be of thickness, this portion और this portion को add कर दो, so of thickness T minus X with area of plate A. ठीक है, and here there is vacuum, so simply you have to add two capacitors in series. Done it? And that way you will get the answer. Even if you are adding the three, you are getting the same thing, but there is no point of doing more calculations and all. Just look at the things कि दोनों ही रीजन में वैक्यूम है, दोनों के विथ को एक साथ जोड़ दो, so D minus X by 2 plus D minus X by 2, D minus X, two capacitors in series. ठीक है, done it? Anyone having any doubt in capacitor? If you want me to explain something more, then you can let me know. I want you to do one thing, please. नीट वाले सारे बच्चे कान खोल के एक चीज सुनते रहो, please. Every day solve more number of questions. There are some suggestion I would love to give. Thing is कि physics में questions are not that difficult. It's not brainer. It's not something that is taking more of your time. It's something that just requires your basic understanding. So in a single day, you can solve as many questions as 30, 40 or 50 questions every day in physics. From suppose 5 chapters you are picking every day, and then you are taking 10 questions from each chapter and doing it. Please do it, because doing 50 questions won't kill your more time, and you should be solving. Done it? Because in NEET what matters is how many number of questions you are doing. Concept wise it's not difficult. So get into more rigorous practice. Still मैं बोलूंगी तुम लोगों के पास कितना दिन बचा हुआ है. Today it is 16 or something, right? If it is 16, still you have with yourself good 20 days, है ना? Or if every day you are solving 50 questions, how many questions you will be able to solve? Still 1,000 questions, and 1,000 questions make sense, right? It is going to add to your practice. It is going to revise your formulas. It is going to boost your confidence, and ultimately it will appear as a rise in the marks that you will be getting finally in your NEET examination. So minimum 50 questions, I'm telling, minimum 50 questions every day you should do. Select 5 chapters each day, and in 7 days, how many chapters will get repeated? 35. So it's a good practice. Do it, please. Everybody do it. Chemistry में और number of questions करो, 100 करो. Do hell lot of practice. इतना practice करो ना कि कोई भी क्वेश्चन दिखे तो तुम्हें लगे कि ठीक है मैंने एक बार सॉल्व किया है. Do hell lot of practice, I'm telling. Biology में ठीक है, you need to give more time. More number of questions will be also there. Syllabus is also vast. Maybe some things you will forget if you're not revising it time and again. But again, revising doesn't mean always you're opening the book and then going through all the concepts or all the things. Sometimes it's also good to go through what questions. ठीक है, so do questions. But in biology actually revising is important. बुक के थ्रू भी रिवाइज करना important हो जाता है. फिंगर टिप्स है ना, एक बुक है, वहां से भी तुम लोग रिवाइज कर रहे होगे. सो देयर एवरीथिंग इज लाइक स्टैक. तुम्हें लाइन बाय लाइन पढ़ना नहीं है. सारी जो होता है ना, आई मीन व्हेन यू आर taking juice, you just take that filtrate out and you take the nutrients in. That filtrate is also important though. But and fingertip is like that. It's taking the juice of book out and it is just getting everything stacked over there, and then you just have to go through those lines. तो काफी हेल्प करता है वो चीजें, है ना, खासकर एग्जाम के लास्ट 20 days और 15 days में. सो आई विल से कि प्लीज तुम लोग लेजी मत फील करो. दिन भर सो नहीं प्लीज. रात में ज्यादा जगो नहीं. रील मत देखो. टेक्स्ट करने में टाइम वेस्ट मत करो. कोई नई मूवीज मत देखो. आई मीन व्हाई यू पीपल आर वेस्टिंग योर टाइम इफ यू आर डूइंग, आई वुड से it is not going to benefit you. What is for you is good as of now is that you are putting so much of work into getting for yourself a good college. Please do for it. I mean, कुछ भी करना पड़े करो. कुछ भी, anything I would say. कुछ भी करो. दिन भर पढ़ो. ठीक है. और प्लीज डाइट सही से लो. स्ट्रॉन्ग ज्यादा नहीं खाना है, हेल्दी खाना है. ठीक है. ज्यादा खाओगे यू विल फील मोर स्लीपी. डन है. डोंट टेक मोर राइस, दैट विल एड मोर टू योर व्हाट दैट इज स्लीप. दो देयर आर सम पीपल जो कुछ भी खा ले उनको नींद सही से नहीं आएगी, आई अंडरस्टैंड. बट यस, कुछ लोगों को बहुत लेजीनेस होता है व्हेन दे ईट अ लॉट. सो इट शुड नॉट हैपन. डन है. तो तुम लोगों को काम बहुत ज्यादा करना है. जब भी क्लास के बीच में भी गैप मिले ना, डू सॉल्व लॉट्स ऑफ क्वेश्चन. जब भी अभी यहाँ पे मैंने कैपेसिटर खत्म किया, तुम लोगों का टारगेट ये होना चाहिए कि कैपेसिटर का और 20 क्वेश्चंस निकाले और जल्दी जल्दी सॉल्व करें. एवरी डे व्हेन आई एम टेकिंग चैप्टर्स, उसके बाद 20 क्वेश्चन तुम खुद से निकालो एंड यू डू इट. सो सारे ही सब्जेक्ट के लिए ऐसा करो. आई वॉन्ट यू पीपल टू स्कोर गुड. और इससे तुम्हारे टेस्ट में भी स्कोर अच्छे होंगे. जो अभी टेस्ट चल रहे हैं, टेस्ट प्लीज स्किप मत करना कोई भी. ठीक है. सो गिव यू 100%. दैट इज व्हाट आई वांट टू से. इफ यू हैव एनीथिंग टू आस्क लेट मी नो. अदरवाइज वी आर गुड टू गो. चलो, किसी को कुछ कहना है तो बोलो. कोई डाउट है, कोई प्रॉब्लम है? यू कैन लेट मी नो. नो. चलो ठीक है. ठीक है देन एवरीवन, ऑल द बेस्ट. तुम लोग करो. कल हम फिर मिलेंगे, बट with different set of question. मैग्नेटिज्म को करेंगे and we will do questions also. ठीक है. चलो, बाय एवरीवन. टेक केयर ऑफ योरसेल्फ.